off at page 216. Remember, we're talking about ratio reasoning today. So this is what our standard is. This is, again, one of your pivotal standards in all of 6th grade. Most of what we do for the rest of the year is going to come down to ratios. You really need to understand this. Okay, Mitsu says, I see another equivalent ratio from Carla's work. Is Mitsu correct? Explain her reasoning. So, go back to the previous chart. You can look at Carla, who did the double number line. Goes back 2 pages now. So there's Carla's double number line. And he's added an additional interval on there. See if he is correct. Or see if she is correct. Sorry, I thought Mitsu was a boy, but apparently Mitsu is a girl. Okay? Figure out if she is correct. Explain her reasoning. And then we'll do number 7, guys. We'll give you guys about 4 minutes to go over number 6. You can talk about it as a table. Go ahead and go. Okay, as we look at this. Is Mitsu correct? Who thinks Mitsu is correct? Raise your hand. Hands down. Who thinks Mitsu is wrong? Raise your hand. Okay, most of you said correct. So who can tell me why she is correct? So don't.
Because they're all divisible by a multiple of 5, and they all come out to 6 on Earth and 1 on the moon.
Awesome! You remembered the definition of an equivalent ratio, which is if I take each of them, 30 pounds on the Earth, 5 pounds on the moon, I can divide both those by 5, which gets me 6 pounds on the Earth to 1 pound on the moon. And my second one is 120 pounds on the Earth and 20 pounds on the moon. I can divide both those by 20 doesn't divide by 12. Well, I mean, if they end in a 0, there's an easy one. I can divide by 10, right? Gives me 12 pounds on the Earth, 2 pounds on the moon. Can I divide that by 2? Gives me 6 pounds on the Earth, 1 pound on the moon. If you saw 20, you could do it in 1 step. But again, use your 4 key numbers and 10s especially. They will get you there faster. And then 150 pounds on the Earth and 25 pounds on the moon. What can I divide both those by? 5. For those of you that see 25, that's great, but quite frankly, it's easier to do 5 twice. So that gives me 30 pounds on the Earth and 5 pounds on the moon, which I can divide by 5 again. Give me 6 pounds on the Earth, 1 pound on the moon. So are they correct? Yes. Okay. She, and we don't know that she simplified, but this is the best way to do it. If they simplify to the same number, they are equivalent. That is the definition of equivalent ratios, guys. If they simplify to the same number, they are equivalent. So if you're asked to show if ratios are equivalent, the easiest way is simplify them. Because you have 4 key numbers to worry about, 2, 3, 5, and 7. As you learned in your math minute today, 11 is your next one. But hopefully most of you are aware, if I see a number that has the digit repeated, that's divisible by 11. Yes, ma'am. Technically, she didn't use additive reasoning. Actually, she could have. So if you did 30 plus 120, that's 150. 5 plus 20 is 25. So good job, Gabby. Okay, Gabby. Gabby got that one right. So that is another way she could have done it, was just using additive reasoning. 30 plus 120 is 150. 5 plus 20 is 25. And if we actually went back to the double number line, you could actually see that had I continued that for one more interval, my next interval would have been going up by 30, 150, going up by 5, 25. That's a terrible 0. Let's try that again. Make sense? Yes, that's excellent. Okay, so now that you've done that, let's go ahead and look at the next one. Show a different strategy to verify the equivalent ratio of 150 to 25. So using these numbers, what could I have done? We could have done what Gabby just said. I could have said, okay, 30 plus 120 gives me 150. 5 plus 20 gives me 25. What type of reasoning is that?
Additive.
Additive. Reasoning. Could we have done a different way? Instead of adding, what could I have multiplied 30 by to get to 150? Could have multiplied by 5. Then I do 5 times 5, and I get 25. So you could use multiplicative reasoning as well, right?
Yeah.
Guys, what we're trying to get you to understand is when you are given a ratio table, it opens up a whole lot of options to you. You can look at additive reasoning like Gabby did, find two numbers that I can add together. Just make sure when I'm doing additive reasoning, I need to add the individual parts. Because I added 120 here, I don't add 120 to 5. I have to follow in that same column. So I need to add those same values together, 30 to 120, 5 to 20. If I do multiplicative, then I'm multiplying by the same number. Because if you really look at it, by multiplying both of those by 5, 5 over 5 is what? 1. So in fact, I multiplied it by 1. Make sense? Any questions on that page? Okay, let's go ahead and go to our next page. Okay, the school has planned a pizza party. They're in charge of ordering for 450 students. The pizza parlor said 2 pizzas would serve 9 students. Tracy started a ratio table to help her determine how many pizzas to order for 450 students. Complete Tracy's table and explain her strategy to determine the number of pizzas needed for 450. In other words, they're asking you to show her work. Does that look familiar to everybody? Should. That's what we've been training you since we started the ratio tables. All we're asking you to do is fill in the blanks for how they got there and then add in this last value. Once you've done that, complete the table to show the number of pizzas to order for any given number. Explain your calculations. Guys, does this explain my calculations?
No.
Yes, it does. It's showing me where I started and what I did to get to the next number, right? Here's your key on this one. They've given me all of the students, yes? But you have to look at the numbers. Notice, this went down, right? So is my pattern on top going to keep going up? No, it's going to go up and down based on what this number is. So make sure you're looking at these numbers on the bottom, figuring out how did I go from wherever you want to start to that number, and then show us your work for how you're filling in the blanks. There are an infinite number of correct answers on this. You just need to show us how you're doing it. Once you've done that, you can then use your table values to answer these 3 additional questions. So we're going to give you guys about 10 minutes to finish up this page. Any questions before we get going? Okay, you have 10 minutes. Go ahead and go. Okay, guys, so back on our first one, all we're doing is filling in our work. How did you go from 2 to 10 and 9 to 45? Times 5. That is showing your work on these charts, guys. When I give you a table and ask you to show your work or explain your reasoning, that's literally all you got to do. Okay? How did I go from 45 to 450? Times 10. So what am I doing on top? Times 10, meaning I have an answer of 100. Guys, it literally should be this easy for you. Okay? Our second one. Now they've given us a whole bunch of empty boxes, but they're kind of forcing our hand because they kind of went all over the place on the bottom. So you have to pay attention to our numbers. How could you get to 450? Who can tell me how you did it? Yes? 9 times 50? Okay. So he came all the way back, then times 50. Personally, I would have done 45 times 10 is 450, but this one also works. Either way, you're going to get 100. Now's where you end up with a bunch of different options. How did you get to 135? What do you think, Vivian? Good, that's what I would have done. 45 times 3. So what am I doing to the 10? Times 3 gives me 30.
Guys, even if you started in a different place, you should still get the same answer.
Yes, as long as your math is correct. If you're doing the same thing, and when you're multiplying, you should be getting the same answer. What about 270? Yes. 9 times 30. Okay, good. So you came all the way back and went times 30. So 2 times 30 gives us 60. Personally, I would have just doubled 135, but that works as well. What about 225? I don't. I try to use the numbers they've given me. 225, guys? Nobody? 9 times 25. So now we're doing 2 times 25, which gives us 50. What about 900? Storm? 9 times 100. I'm going to do a different one. I'm going to do 450 times 2. Gives me 100 times 2 for 200. What about 1350? Soon?
150 times 3.
Okay. I'm going to go a little different. I'm going to say 450 plus 900. And so 100 plus 200 gives me 300.
Couldn't you just do like 9?
Again, there's a whole bunch of ways. Literally, you can get to any one of these from any other one. A lot of them you'll have to use decimals or mixed numbers, but you can literally go from any one to any other one. I want you guys to get used to using both additive and multiplicative reasoning. One advantage to a ratio table, guys, is I can use additive reasoning. So if I see two numbers like the 450 and 900 that easily make one, you can just add them. You just have to add the corresponding values with them. Multiplicative is going to be your most common because when we're doing fraction forms, you're basically always going to use multiplicative. But if they've given me a table, look for additive. A lot of times additive will be easier, especially when you have larger numbers like that. Does everybody understand how to show your work? Yeah. This will be really critical on your homework tonight. So make sure you understand how we're doing this. Okay, so use your table of values to answer each of the questions. So how many students will 12 feed? Well, look, if I want 12, I can just add those, right? Yep. So 2 plus 10 is 12, so I'm going to add 9 plus 45 equals 54 students can be fed. How many will 20 feed? Well, I could use my table. I can do 30 minus 10, or I'm going to just use this one and double it. Okay, so 45 doubled is going to give me 90 students can be fed. And what about 90 pizzas? Given what we've got, I would probably just do additive because I can add those two together to get 90, right? So if I add those two together, I'm going to get 405. But 90, I could have just taken 30 and tripled it and tripled that if you wanted. 90, I could have taken 10 and done times 9, 45 times 9. There's a whole bunch of different ways you could have done it. Could have done 100 minus 10 if I wanted to do that one. 45 minus 450 minus 45. Okay, so lots. Again, guys, this is one of the big advantages to a ratio table. It gives you a lot of ways to get to the answer in either multiplicative or additive reasoning. But I'm actually with Ms. McShannon on this one. Try to focus on your multiplicative first, because that one is going to also carry over when we're doing it in fractional form. Any questions on this page? Okay, let's go to 218. And just for the record, Mrs. McShannon's still not feeling great. That's why she's not on the recordings at all today, because we don't want her wheezing in front of everybody. Okay, so we started this chapter, this section, with green paint from Riverview Middle School. So we go back to that. Remember, it takes 3 parts blue to 2 parts yellow to create green color. They want to mix different quantities for several school projects. So we thought they needed a table to help determine the correct amount of each color for the different projects. Sally does some reasoning. We've already warned you it's wrong. So we want you to explain what is wrong, but then we want you to complete the table. Now I'm going to give you a little help on this first one just to make sure everybody understands what you're doing. The key is you've got to focus on what they've already given you. So if I've already got 5 and I'm going to 15, what do I need to do? Times 3. So my work is going to be times 3. Guess what I'm going to do on the other ones then? Times 3 gives me 6 pints. And then times 3 gives me 9 pints. Does that make sense? So it's literally what we've been doing. We're just adding an extra layer to the table. Just make sure you're filling in all 3, but you've got to go based on the information they've started and show us your work. Show us how did you get there. Any questions on what you're doing? Okay, you have 7 minutes. Go. Okay, our first one. Sally said if I want 15 pints of green, then I will need to add 10 to the original 5 total to get 15. Is that correct? Is everybody okay with that? Okay, so that's okay. So I should add 10 to each of the other numbers to get 12 pints of yellow, 13 pints of blue. Is that correct? Why not?
Using additive reasoning for the first type, so you can't just like use one of the steps in the multiplicative reasoning and add 10.
That is such an awesome answer. She used all the right math terms and everything. Great job. That was perfect. So, what the problem is, she's looking at additive reasoning, right? So she started with additive reasoning.
Make sure we're writing this down.
She added the parts. Then switched to multiplicative reasoning. In which she used the same numbers. You can't switch between the reasonings, guys. If she's going to add 10 on the 15, that's fine. Okay? So starting at 15, she added 10. But then I needed to double this, right? Because 15 is double of 10. So I need to take my parts and add double of it for each one. So if I'm adding 10 to get to 25, then I need to add 4 to the 6. I need to add 6 to the 9 to keep them equal. In additive reasoning, I'm using the individual values. In multiplicative reasoning, I'm using the same number. That's why the multiplicative is easier. Additive reasoning really only works if my table is already started. I'll be honest. Other than that, you're not ever really going to use additive reasoning. Multiplicative is your go-to. Does everybody understand that? Anybody not understand why she was wrong? Okay, so it looks like we're good on that. Okay, let's go ahead and complete our table then. So looking on this one, our next one was going to 12, right? How do I go 3 to 12?
4.
Times 4. So what am I doing to the 5? Times 4, which gives me 20 pints. Okay, how did you get to the 18? Times 6, okay. Some of you could have started at 9 and gone times 2.
I could times 3.
I don't know what you did times 3.
Because you wrote it down.
No, that's to get to the 9. To get to the 18 is times 6. So I'm going times 6, which gives me 30 pints. And I'm also coming back here, don't forget this part, times 6, gives me 12 pints. Now the last one might have thrown a few of you off. 1.5. How do I go from 3 to 1.5? Divide by 2. So I'm going to divide by 2. So I go back here, I'm going to divide by 2. That's going to give me 2.5 pints. And I come back to here, and I divide by 2, that's going to give me 1 pint. Okay, questions on this one? Okay, our next page. And I'm just going to go through this with you because we're down to 7 minutes and I still want to get over the homework. So Charlie said the table's helpful, but it cannot list every amount we might need for every painting. I think if we multiply 2/5 times the total amount of green paint, then we can determine the amount of yellow paint needed. If we multiply 3/5 times the total amount of green paint, we can determine the amount of blue paint needed. So let's look at this for a second. So he's saying 2/5 of the green gives me yellow. If I go back to my table, and I say, okay, it's 5 times 2/5. That equals 2. Did that give me the amount of yellow?
Yeah.
Yeah. If I look at my numbers, what's 2/5? What kind of ratio would it be? Yeah, it's a part to whole ratio, guys. All they did is they took the simplified version and they turned it into a part to whole ratio, right? So, would that work? Will that always work?
No.
Yes. He just made it a part to whole ratio. Now the key on this, you have to keep your parts straight. I need to understand that 2 is the yellow, 5 is the total green, and then it's always going, it's basically just an equivalent proportion, right? It's saying 2 of the yellow and 5 green. If I'm always multiplying any number by that, I'm going to get equivalent ratios, right? If I'm multiplying both by 10, that's going to be 20 and 50. Is that equivalent? Yeah? If I'm multiplying both by 5, that's going to get me 10 and 25. Is that equivalent? So will that always work? Yes. He just used a part to whole ratio. And multiplicative reasoning.
For those in the back.
Oh, the people at home just missed a really good one on that one. Okay, Charlene said, I'm thinking about it a little differently. The amount of blue paint is always 1.5 times as much as the amount of yellow paint. So if I look at this, so 1.5, so 1.5 is 3/2, right? So 3/2 times 2, the amount of yellow, equals 3. Did that give me the blue? Will that always work?
Yes.
Yes? What type of ratio did she use? Part to part. So yes, she used a part to part ratio and multiplicative reasoning.
You guys are good. Just start writing and keep writing. You know he's moving on. At least you'll know where you're at when you want to.
It's okay, I've got first lunch, so I can always do the homework in lunch. And our last one. His is related. It's yellow is 2/3 of the blue. Is that correct? Yes, it's another part to part, guys. Yes, he used part to part ratio. Used a part to part ratio. And multiplicative reasoning.
I think you have broken your students. I'm just saying.
Guys, does everyone understand what we're talking about on these? Is it making sense for you?
Yes.
Okay.
Yes.
I'll give you about 30 more seconds to get this one written down. Again, multiplicative reasoning on these tables is always going to be your best option, quite honestly. Try to look for your multiplicative reasoning first, but if you see something that goes together easily, don't be afraid to use additive reasoning. Just make sure you're adding the parts, not the same number. Okay, let's go to our homework real quick. Guys, quiet down. I didn't say to put it away, David.
No, this was a different homework.
Okay, describe how you can use addition within a ratio table. Use examples. So I've given you plenty of examples in our homework, or in the work we did. Feel free to use an example from that. Each table represents a ratio, yellow to white. Explain your calculations. That's showing your work, guys. Here's the part that almost everybody missed last year that took forever to grade this. How did I go from 9 to 36? Times 4. So what am I doing to the 15? Times 4, that's going to be 60. Guys, this is your work. That explains your calculations. If you do not have that, I will not grade it. You must show your work. So you're going to do all 5 tables on the back page. Hold on a second, guys. Now, they gave you specifically 99 yellow daffodils. That means I'm adding a column here for 99 to show me how you got there. How can I use subtraction? We haven't talked about that, but it's just the opposite of addition. Find 2 that go together that you can subtract to get the answer for 40 white daffodils. Good luck, guys.